Hello everyone. As you can see on the top right hand side, my name is Siddharth Devineni. As you can also see on the board there, I'm going to be talking about friction. So before we get into it, let's just define what friction is. Friction is the force resisting relative motion between two bodies. It's pretty easy actually. In other words, friction is a stopping force. Friction opposes motion. Best example of friction in the real world is between your car and the road. If there was no friction between the car and the road, your car would slide and it would be very difficult to drive. It's a bit like it would be like driving on ice, where there is no friction between your car and the road. You'd slide everywhere. You'd struggle to brake. You'd struggle to accelerate, etc., etc. So the best way to, understand friction is I'm going to just do a quick textbook problem from the Miriam and Craig Engineering Statics textbook. Pretty simple problem that explains friction well. So we've got a box. The textbook doesn't actually define what it is, but I'm just going to assume it's a box being pulled by force P, which acts on the center of the body at an angle of 30 degrees. And the question is asking us to find the frictional force being applied against this body. So, obviously this body could either be static or dynamic. To answer this question, the best thing to do is just to assume that it is static. But before you do that, of course, draw a free body diagram. So in this case, if it's static, it's got mg acting down, the weight of gravity. It's got a normal force. And I said that friction opposes motion. Well, in this case, this thing is being pulled from left to right. So friction must be acting from right to left. Pretty easy. Define your axes, x, y. Now it's static, so let's use equations of equilibrium to find F and N, and also, P equals 700 newtons. So we'll just go here, F of x equals 0, taking left to right as positive. So it's pretty straightforward. We just go 700 cos 30 minus F equals 0. F equals 606 newtons. So that's the frictional force acting on this thing if it was static. We don't know if it's static or not. That's what we're trying to determine, and then after that we can find the frictional force depending on whether it's moving or not. Then we take F of y equals 0, up is positive. Again, pretty basic stuff really. N minus 981 plus 700 sine 30 equals 0. mg equals, this is 100 kilograms, by the way. So 100 times 9.81, which is 981 there. So just write that here. mg. And 700 sine 30. So 700 cos 30 is the x component of this p. 700 sine 30 is the y component of the p. We're just finding n and f. So from here, and sorry, I apologize for the messy writing. N is equal to 631 newtons. 31 newtons. So you can see there. So I'll just write that here just to make it a bit clearer. F is 606 newtons. N is equal to 631 newtons. Okay. So we've got that. And one thing I forgot to mention was mu s and mu k. Mu s, I'll just do that properly. Mu s is 0.8. Mu k is 0.6. So what is mu s and mu k? Well, mu s and mu k are just the coefficient of frictions. Mu s is the static coefficient of friction, and mu k is the kinetic coefficient of friction. Right, so from here we want to find the maximum coefficient of friction if the body is static. So we use, and I'm just going to rub this out, which is need to create some space. Sorry, let's just get rid of this. So we use F max equals mu Sn because we're assuming that this thing is static. So this is the maximum frictional force that can be applied. Maximum frictional force is the same thing as saying the minimum amount of force needed to push the body if it was static, to overcome the friction between the body and the ground. So that's what F max is. So that is equal to 0.8 times 631, which is equal to 505 newtons. Now, the maximum frictional force is 505 newtons, but from our equations of equilibrium, we have found that F is 606 newtons. So what does that imply? Well, F is greater than F max. I'll just write that here. Greater than F max. As I said, F max is the minimum force required to push the body along the ground. Now F is bigger than that, which means that there must be a bigger force than F max pushing the body along the ground. Therefore, it is moving. Therefore, moving. If F max was less than F, therefore static. Just fix that up. Static. Okay. So what do we do then? Okay, we use the formula F equals UKN to find the frictional force. And remember, UK is the coefficient of friction when the body is moving. So then that answer just becomes, oh sorry, I'll just rub that out. Answer becomes 0.6 times 0.6 times n. N was 631. And that answer is 379 newtons. Okay, so that's the answer. So what have we done here? So first things first, sorry, we've drawn a free body diagram. We've assumed it's static. So we've used equations of equilibrium in statics. In the x and y direction, we found the frictional force and the normal force. We've then gone and found the maximum frictional force, or rather, maximum frictional force, between the body and the ground if the body was static, which is 505 newtons. We have observed that F is actually bigger than F max, so that means that it must be moving. So since it's moving, we use mu k, and so we've got mu k times n, which gives it 379 newtons. 379 newtons means that this body is moving, and the frictional force opposing the motion is 379 newtons. So that is essentially how you solve a basic friction problem. You'll get situations where you might have a body on a slope. So just rub this out. Just draw a quick rough diagram of a body sort of on a slope like this. So you got a slope like that. You got mg and say you got this force P pulling it, so you got F like that. So my tip would be to define your axis like this. X, oh sorry, wrong one. Apologize for that. Like this, X, Y, and it's just the same process. You just draw your free body, find your F and N using your equations of equilibrium, assume it's static, of course. Compare your value of F to the F max. Use some logic and try to use some logic and try to sort of figure out if it's moving or not. If F is bigger than F max, then it's moving. If F is smaller than F max, it's not. And then from there, just use mu n, either mu s or mu n, according to whether it's moving or not, to find your frictional force. And that's pretty much how you solve a friction problem.